Okay, so Mr. Rops here, and today we're going to talk about the unit circle. And the key to a unit circle is it's a circle that has a radius that is equal to 1. So if that's the case, the center is going to go over this way. This is 1. So this is the coordinate point 1, comma 0. This one here will be 0, comma negative 1, and so on and so forth. So every line is worth 1. And so what I'm going to do is I'm going to come along here and I'm going to put a line here. I know this length is 1, and this angle I'm going to call theta. Well, this coordinate point here is x comma y, and if I draw an angle straight down to the x-axis so that it's perpendicular, I've created a right triangle here. And if I consider this distance here, which I know is x, right? This is x. Well, if I consider x, theta, and 1, this is adjacent. So I know that the cosine of theta is equal to x over 1. So cosine theta is equal to x. This distance here is x. Cosine is x. Similarly, if I look here, this is my y. I go over x and up y. If I look at y, theta, and 1, I know that this is opposite. This is hypotenuse. That is the sine of theta is equal to y. And so what I know is that every point on the unit circle can be expressed as cosine theta, comma, sine theta. Okay, because I know I go over x and up y, and so this is the same thing as saying cosine theta is x, sine theta is y. And so it's really important that you remember that cosine and sine is x and y on the unit circle. An easy thing to help you to remember which is which, C and S are alphabetical, as are x and y. You know it's adjacent is the x, so cosine, opposite is the y, which is sine. Okay, and so I have sine and cosine, but I also know that tangent theta is equal to the opposite over hypotenuse, or sorry, opposite over adjacent. So tangent is equal to y over x, but if I know y is sine, x is cosine, and so tangent theta is also equal to sine theta over cosine theta. That's a handy rule to remember. That's an identity that's always true. And so the idea, the whole power of the unit circle is that every single point here can be expressed in terms of cosine and sine of the angle from this position here. So that would be theta, this would be theta, and so on. Okay, but we also have to remember we have reference angles. Let's do a little example of some scenarios here. So now it says, using the unit circle, I want to find the sine of 90. Well, remember if I have my unit circle, here we go, unit circle, and let me find my circle tool here. I'll do my circle, okay. I know if I look here, 90 degrees is to there, there's 90. And this coordinate point here is 0, comma 1. Well, if I remember, the x value is cosine of 90, the y value is the sine of 90. So the sine is this height here, and is equal to 1. Similarly, if I want to do the cosine of 270 degrees, if I start here, I go around 90, 180, 270, here I am here. And so here's the coordinate point, which is 0, comma negative 1. Cosine is the x value, so the cosine is equal to 0. Okay, now I'm going into tangent now. Tangent of 90, well, I can go back to this coordinate point. I know cosine of 90 is 0, sine of 90 is 1, and so the tangent of 90 is equal to the sine of 90 over the cosine of 90 degrees. Because if you remember, that's another formula for tangent, sine over cosine. And so, well, I plug values in. Sine of 90 is 1, the cosine of 90 is 0, And 1 over 0 is undefined. Okay? This is not 0. It's not no solution. It's undefined. And so finally, the last one we'll take a look at is we'll do the tangent of 180. So 180 degrees puts me to here. Here's my 180. This coordinate point is -1, 0. And so now I know it's going to be equal to the sine of 180 over the cosine of 180. The sine of 180 is the y value, so 0, over the cosine is the x, which is -1, and so that is going to give me 0. So here's a quick introduction to the unit circle. It does get